Okay, I would like to summarize what all I did in the iLabs for this particular module, for the malware module. Okay, in iLabs, we saw engineer demo where a Trojan is created on Windows 10 machine. The created Trojan is transferred to Windows 2016 machine, ran there. After running on attacker machine, that is Windows 10, we can see various options like keylogger, remote connection, chat with victim, etc. And in the second practical, the Trojan was created as in previous lab, but it was encrypted. Actually, the same Trojan created in the previous lab was encrypted by using the tool called Sways Crypter, and then transferred to Windows 2016 machine. We also saw the number of red flags reducing on virustotal.com after encrypting. The encrypted file also worked the same way as seen in the previous lab. In the third lab, we used ProRat, ProRat Trojan. We created a server just like in the first lab, but we binded the exe to a JPEG file containing a car picture, which was then opened on the victim machine. Once the JPEG file is opened or the Trojan is run on Windows 10 machine, we could get access for the Windows 10 machine in our attacker machine. Okay, we also saw how to create a virus using JPS virus maker tool. We used virustotal.com and explored various options in virustotal.com. Usually, we only see the how many red flags are raised by various uh, virus scanner websites. But in this lab, we got to know that there are so many other options which we could explore in the virustotal.com. We then used a bintext tool on face.exe virus. It showed various strings used in the virus. The strings contained many API calls. We could also see DLLs. The type of string is designated by colored letter to the left of the list. ANSI strings are marked with the green A. Unicode strings, double byte ANSI, have a red U, and the resource strings have a blue R. I did not find any R, might have missed it. It contains columns, file pos, mem pos, ID, text fields displayed in different columns. File pos is the hex position at which the text is located in the file. Mempos, if the file is a Win32.pe file, such as Windows 95 exe and DLLs, then this is the hex address at which the text is referred to in the memory at runtime as determined by its section table. ID is the decimal string resource ID or 0 if it is not a resource string. Okay, ID is the decimal string resource ID or 0 if it is not a resource string. Next, we used a tool PEID to identify packaging and obfuscation methods. In the next exercise, we used PE Explorer to find portable executable information of a malware. We saw dependency worker list, which lists all dependency models of an executable file and builds hierarchical tree diagrams. Dependency worker is actually a very good tool. It also records all functions that each module exports and calls. Further, it detects many common application problems such as missing and invalid modules, import and export mismatches, circular dependency errors, mismatched machine modules, and module initialization failures. We could view all available DLLs for the malicious file. In this case, it was snoopy.exe, which is a virus. We selected one DLL to see the details. In the next lab, we performed malware disassembly using IDA and Ollie debug. Ollie debug, it did not show an assembly code, but it shows flowchart, call tree. We can also view hex view structures, etc. Sorry, I forgot. I think it showed assembly code. It showed flowchart, call tree, and we can also view hex view structures. In the Ali debug tool, it it showed assembly code in the CPU main thread window. It showed registers window. We could see a log window, um, executable modules. In the executable modules, we can select any module and queue assembly and view assembly code in CPU and in the which is in the main thread window. We can also view memory view, thread view, etc. Dynamic analysis lab, we saw port monitoring using TCP view. On TCP view main window, we saw the details such as process ID, protocol, local address, local port, remote address, remote port, and stat. We can see the process Trojan dot running. Actually, before opening the TCP view, we executed the Trojan.exe in the background, and then we monitored the ports. When we go to the properties of this process, we can see the path as well. We can also end process. We also used CURR port tool similar to TCP view. CURR port curve port also shows almost same details. We can select the Trojan process and see the properties. It shows the path, IP address of the attacker, port. Here also we can kill the process. We can also select close selected TCP connections. If any connections are open, we could close the TCP connections. So when we right click on the process, so by right clicking on the process, we can close the connections if we find any open connections. We also used process monitor which showed PID, operation, path, result, and details. In the properties, there were three tabs: event, process, start tabs. Process tab was interesting. It showed usual things like PID, path, a parent PID, etc. It also showed modules, its address, size, path. It showed a trojan.exe, its path, address size, etc. It also showed DLL list used by the Trojan process. In the stack tab also it showed supported DLLs, their addresses, path, etc. Then registry monitoring using regshot and GV16 tools. Using regshot, first we will take a first shot. The first shot was stored on the desktop. After taking the first shot, we installed some application. After installing, took a second shot and saved as shot 2. There is a compare button on the rec shot used to compare. It creates a result.html file. Open with Microsoft Edge. You can see the differences between shot 1 and shot 2. It will also show unwanted registry entries which can be deleted. JV16 power tools for monitoring the registry. So actually in this lab we installed the uh, JV16 power tool, and it shows home options as default. So in that we click the main tools, lists available tool features. JV6 power tools. Within that main tool, there are many tools. So first, it shows the available tools. Then click the clean and speed up my computer icon. After the completion, it shows registry errors. Te- After the cleanup, it showed registry error, temp files, and other results. To view registry error, expand registry error node, and then expand the invalid ActiveX DDE com decom OLE item node. We can see the registry errors. In the same way, expand the other items in the list to view all temporary files, log files, and other data. Select all the items in the application window and then click delete. After deleting, again go to main tools and click control, which program starts automatically. You could find any trojans or malicious files running at system startup and choose the appropriate actions against them. After main tools, select registry tools. This section helps you to find, manage, monitor, compress, clean, or replace registry files. Click file tools to view file related functions. This section helps you to find, recover, clean, organize, or merge files or directories. Select privacy tools to view privacy related functions. This section helps you to check for vulnerable software, spyware, clear your history, and perform other tasks. Select backups to view the system related backups on main menu, not in privacy tools menu. Backup tool windows appears, displaying the registry file and other backup. You can choose whether to delete or restore backups in this window. Examine the result of JV16 powered tools can reveal unwanted registry entries and other suspicious activities on the machine, and allows the user to stop or delete them. Next, Windows Services Monitoring using Windows Service Manager SRV man. In this tool, you can view services, start a stopped service, stop a running service, or restart a service, etc., and perform startup monitoring using auto runs for Windows and another tool called WinPatrol. So in the auto run tool, click the logon tab to view applications that run automatically during login. Click the Explorer tab to view Explorer applications that run automatically at the system startup. Click the Services tab, displays all services that run automatically at system startup. Click the Drivers tab to view all application drivers that run automatically at the system startup. Click any drivers to display its size, version, and the time at which it was automatically run at the system startup for the first time. Click the known DLLs tab to view all known DLLs that start automatically at system startup. So similarly, the next tool used to perform startup monitoring is WinPatrol tool. Click the Startup Programs tab, similar to AutoRun. Select any program that affects your system and click Disable. Switch to IE Helpers tab. It shows all toolbars and links loaded by IE or other Windows component. Select duplicate or non-required programs. Here Java TM plugin in SSV Helper and then click Remove. Switch to Services tab to display the installed services on your system. Select any service and click Info. A window showing the service information appears. To disable a service, select Disabled from the drop down list and click Apply. Switch to the File Types tab to view the programs associated with a file. Select a program and click Info to view the available information. Similarly, you can analyze active task. Perform installation monitoring using Microsoft. Click the Programs tab to view the programs installed on your machine. You can choose any unwanted or unused application and click Uninstall. Click the Performance tab to view and terminate currently running programs. Here you can select any program from the list and click End Program to terminate the program. Click the Startup tab to view the programs that run automatically on Windows Startup. Perform files and folder monitoring using PA file set. On PA file side, we can set to monitor a folder on any system, and you can monitor that particular folder. In the lab, we monitored Windows 2016 machine from another system, that is from Windows 10 machine. We created a file in Windows 2016 on a folder that was monitored. It was recorded by the PA file site. We typed some text in the file which was in the folder that was being monitored. This event was also shown by the PA file site tool. Perform device driver monitoring using driver view and driver reviver. Driver view, the driver view utility displays a list of all device drivers currently loaded on the system. For each driver in the list, additional information is displayed, such as load address of the driver, description, version, product name, and developer. Driver reviver, without proper drivers, computer starts to misbehave. Sometimes, updating the drivers using conventional methods can be a daunting task. Outdated drivers are more vulnerable to hacking and can lead to a breach in the system. Driver Reviver provides an effective way of scanning your PC to identify out of date drivers. Driver Reviver can quickly and easily update these drivers to restore optimum performance to your PC and its hardware, and extend its life. Driver Reviver shows each driver and its status like updated or outdated. If the drivers are outdated, then you can click Update All button to update all the driver. Perform DNS monitoring using DNS Query Sniffer. Open DNS Query Sniffer. Check WinPcap packet capture driver. In the Select Network Adapter section, select the Windows 10 network adapter. Here it's Ethernet 2. Click OK to start sniffing. The DNS query sniffer starts monitoring the network traffic and takes some time to capture the traffic. Leave the window intact. It shows the DNS query sent on your system along with its complete information such as host name, port number, request time, response time, duration, source address, and destination address. For demonstration purpose, we change the DNS of the Windows 10 machine in the network and internet settings. We changed it to 10.10.10.16. Found that sniffer also the IP had changed, DNS IP had changed. Right click on it and go to properties. It shows all the details. This way we can find if any malicious attacker changes the DNS server.